Hello guys, my name is Aflonce and I'll be talking to you today about Samba. It's from ISA class 4220. What is Samba? Samba is an open source implementation of the server message block, the SMB protocol. It allows the networking of Microsoft Windows, Linux and Unix and other OS systems together by enabling the access to the window-based file and printer shares. Samba uses the SMB protocol to appear as a Windows server to its Windows client. A little background on it. Samba has the ability to join an Active Directory domain using the LDAP and Cobros. It's built in Unicode support. It supports Microsoft XP professional client connections to Samba servers without the needing of the local registry of hacking. Some important features that Samba offers. It has subdirectory trees and printers to Linux, Unix, and Windows clients. It assists in the networking browsing with or without the NetBIOS. Authenticates Windows domain logins. It provides Internet Name Service WINS name service resolutions. It acts as a Windows NT style primary domain controller. It acts as a backup domain controller for Samba-based PDC. And lastly but not least, it acts as an active domain member server. Samba daemons and services. Some of the Samba daemon services we have then SMBD, NMBD, and the WinBind. Two services, SMB and WinBind, control how the daemons are started and stopped, and other service-related features. Each daemon is listed in detail. SMBD. This server daemon provides file sharing and printing services to the Windows clients. In addition, it is responsible for the user authentication, resource locking, and data sharing through the SMB protocol. The default ports on which the server listens to the SMB traffic are TCP ports 139 and port 445. The SMB daemon is controlled by the SMB service. It's good to note. Daemon number 2 is the NMBD. This server daemon understands and replies to the NetBIOS name service requests, such as those produced by the SMB Windows-based systems. These can include Windows 95, 98, ME, Windows NT, 2000, XP, and LAN manager clients. NMBD daemon also participates in the browsing protocols that make up the Windows Network Neighborhood View. And just like SMBD, the ports for the NMB traffic are UDP port 137. And the NMBD daemon is controlled by the SMB service. Daemon 3, WinBind, our service resolves user and group information on a server running on Windows NT 2000 or Windows Server 2003. This makes Windows user group information understandable by the Unix platforms. The WinBind daemon is controlled by the WinBind service and does not require the SMB service to be started in order to operate. WinBind is also used when Samba is an Active Directory member and may also be used when on a Samba domain controller to implement the nested groups. How do you start and stop Samba? To start a Samba server, you need to type the following command: smbin server smb stop. To stop the server command, you need to type in the following command. The restart option is a quick way of stopping and starting Samba. It is considered to be the most reliable way to make a configuration changes and that would take effect after editing the configuration file for Samba. One good thing to note is that the restart option starts the daemon even if it was not running originally. And to start, just type in the following command in your shell prompt while logged in as root. The conditional restart option only starts the SMB on the condition that it is currently running. This option can be very useful for scripts because it doesn't start the daemon even if it's not running. And that's the command you input to start the server conditionally. Some types of Samba servers. We have the standalone server. Standalone server can be a workgroup server or a member of a workgroup environment. A standalone server is not a domain controller and doesn't participate in a domain in any way. Some examples of how it works is the anonymous read only. We also have the anonymous read and write. And we have the anonymous print server and the secure read write file print server. Server number 2 is a domain member server. A domain member server, similar to the standalone server, is logged into a domain controller either by Windows or Samba, and it is subject to the domain security rules. An example of a domain member server will be a departmental server running Samba that has a machine account on the primary domain controller, the PDC. All the department clients still authenticate with the PDC, and desktop profiles and all network policy files are included. The difference is that the departmental server has the ability to control the printer and the network shares. Some of the security modes in Samba are, we have the first one is user level security. There are only two types of security modes for Samba: share level and user level, which are correctly known as security levels. Share level security can only be implemented in one way, while the user security can be implemented in at least 4 different ways. User level security. This is the default setting for Samba. Even if the security user directive is not listed in the SMB file, it is used by Samba. If the server accepts the client's username password, the client can then mount onto it multiple shares without specifying specifically what the password at each instance. Samba can also accept session-based username password requests, and the client maintains multiple authentication contexts by using a unique ID for each logon. Some other implementations, you can implement the domain security mode. In the domain security mode, the server has a machine account and causes all the authentication requests to be passed through the domain controllers. You can also use the Active Directory as security mode, by which if you have an Active Directory environment, it is possible to join the domain as a native Active Directory member, even if the security policy restricts the use of any anti-compatible authentication protocols. The Samba server can join the Active Directory security mode using Cobros. Samba in Active Directory member mode can accept Cobros tickets. We also have the server security mode. Server security mode previously was used when Samba was not capable of acting as a domain server. Share level security. With share level security, the server accepts only a password without an explicit username from the client. The server expects a password for each share, independent of the username. There have been reports where Microsoft Windows clients have had compatibility issues with the share level security servers. Samba developers do strongly discourage the use of share level security. Samba network browsing. We have two types of browsing. Network browsing, it enables the Windows and the Samba servers to appear in the Windows network neighborhood. In the network neighborhood, icons are represented as servers, and if open, the server shares and the printers are available to be displayed. Network browsing capabilities require NetBIOS over TCP/IP. NetBIOS-based environments use broadcast UDP messages to accomplish browse list management. A domain master browser collates the browser lists from a local master browser on all subnets so that the browsing can occur between the workgroups and the subnets. Browsing, Samba network browsing number one, domain browsing. By default, the Windows Server PDC for domain is also the domain master browser for that domain. A Samba server must note to be set up as a domain master server in this type of situation. The Windows Internetwork name server, either a Samba server or a Windows NT server, can function as a Win server. When a Win server is used with the NetBIOS enabled, the UNDP unicast can be routed, which allows the name resolution across all networks. Without a Win server, the UDP broadcast is limited to the local subnet, and therefore it cannot be rerouted to the subnet, workgroups, or domains. If the Win's replication is necessary, do not use the Samba as your primary Win server because Samba is not currently supporting the Win's replication. Some of the best practices for Samba. Practice number one: you can apply user-based, host-based protection. In many installations of Samba, the greatest threat comes from the outside of your immediate network. So by default, Samba accepts connections from any host, which means that if you run an insecure version of Samba on a host that is directly connected to the internet, you can especially be vulnerable. So you can institute the user-based host protection to protect your system. Apply user-based protection if you want to restrict to your user valid users only. The following method can be used to better restrict all the server access, either to the use of Jackal or to members of the system group SMB users. You can also apply user interface protection. By default, Samba will accept connections on any network interface that defines on your system. That means if you have an ISDN line or a PPP connection to the internet, then Samba will accept connections to those links. That might not be what you want. Last but not least, you can apply IPC shares. If the above methods, the ones we've already discussed, are not suitable, you can place more specific deny on the IPC shares that is used in the recently discovered security hole. This will allow you to offer access to the other shares while denying access to IPCs from potentially untrustworthy hosts. And that will be the end of my presentation, and these are my references. Thank you very much.